In this video, we're going to solve the simple macroeconomic model where we have government and net exports added to it. So with the addition of foreign trade and government expenditure into our model, our aggregate expenditure function, so our desired level of aggregate expenditure, now equals C plus capital I plus capital G plus capital NX. So these are the two additions to our model. So we're going to see what effect they have when we've added them to the model. So the first thing we need to do is write out the functional forms we're given. So I'm going to use the functional forms that are in the textbook. So at that point we know little c equals a plus b times yd. So consumption function is equal to autonomous consumption plus induced consumption, where yd equals disposable income. And in this case, yd isn't going to be equal to y because the government is taxing some of our income. We're assuming that investment is again autonomous, so it's just some kind of constant. We're assuming g is also autonomous, so it's just some constant as well. And we're assuming net exports equals exports minus imports. And the functional form that we have there is exports are a constant, so no matter what our level of national income, we're still exporting the same amount. But we're assuming that imports are induced in that, so the higher our national income, the more we're importing. We can afford more goods from around the world, we're going to import more of these goods. So let's put these functional forms into our new aggregate expenditure function. So now we have aggregate expenditure equals A plus B times YD, so that's our consumption, plus I0 plus G0 plus X0 minus M times Y. Okay, now like I mentioned before, in the simplest short run model with no government and no net exports, we could have just subbed in Y for YD because we don't have to pay any tax. But now we do. So now we really need to figure out what this disposable income is. And remember that disposable income is your income after tax. So our disposable income is after tax income. And so it's our income minus however much tax we pay. And we're assuming that the tax takes the following form, where T is the tax rate and Y is national income. So now we can simplify that a bit more, and we have YD equals 1 minus T times Y. So now we have this identity, and we can sub this in way up to here. Okay, so let's sub it in now. Aggregate expenditure equals A plus B times 1 minus T times Y plus I0 plus G0 plus X0 minus M times Y. Now again, just like in the simplest model we saw before, we should group all the terms that depend on Y or that are multiplied by Y, and all the terms that are autonomous that don't depend on the level of national income. So let's just scroll down here, and you can write aggregate expenditure equals A plus I0 plus G0 plus X0. We're just going to put that in brackets, plus B 1 minus T times Y minus M times Y. So these are all the things that do not depend on Y. So they're going to be the autonomous aggregate expenditure. And everything over here is part of the induced aggregate expenditure. So let's look at this second term, and let's just common factor the Y out. So now we have aggregate expenditure equals A plus I0 plus G0 plus X0 plus B 1 minus T minus M times Y. And we'll put that all in brackets there. And so what we're going to do is call everything that doesn't depend on Y, all the autonomous part, just like before, we're going to put a capital A to denote all of it. So everything in this brackets, we're going to put into this variable we're going to call a. And now we're going to say everything multiplied by the y here, we're going to call z. This is going to be the marginal propensity to spend that we've seen. And so now we can rewrite our aggregate expenditure function to be aggregate expenditure equals a plus z times y, where a is all these terms here and z is all those terms there. Sometimes it's just simple to work with. Instead of having to write out a plus I0 plus G0 plus X0 and b times 1 minus t minus m, sometimes it's easier just to group those together in one term. We're going to call a, and another term we're going to call z. Okay, so let's scroll down a little bit. And now we need to invoke our equilibrium condition. And that is that y equals, so real national income equals desired aggregate expenditure. That's still the same equilibrium condition that we had before. So now we have y equals a plus z times y. So I'm just subbing in what our aggregate expenditure function looked like down here. We want to solve for y. And so now we can move the zy over, so we're going to subtract it, equals a. We can common factor the y out, so y times 1 minus z equals a, or y equals a over 1 minus z. And now what we should do is just sub in what we have for this a up here and this z up here to complete our answer. So a plus I0 plus G0 plus X0 over 1 minus B1 minus T minus M. And so now we've derived our equilibrium when we've added foreign trade, so net exports, as well as government expenditure and taxation. So let's look graphically at what we just did, or what it looks like on a graph. And so let's scroll down here. We're going to just get our axis together, just like before. AE is on our y-axis, national income on our x. We have that same equilibrium condition we had before, that is AE equals y. Let's just imagine this is 45 degrees. It looks, not too bad there. And now let's graph our aggregate expenditure function. So this is our function up here. So this is what we're trying to graph. I know it's a little bit messy, but bear with me. And so everything that doesn't depend on y, so that capital A is going to go into the intercept, and everything that's multiplied by y is going to determine the slope of this aggregate expenditure line. So let's say this is capital A, so this is our intercept, and this is equal to A plus G0 plus I0 plus X0 is going to be our A. Then we have a slope, and this slope is going to be equal to B times 1 minus T minus M. And where these two lines intersect is going to be our equilibrium condition that we just solved for. So if we just tick down here, we just figured out that it's y star equals A plus I0 plus G0 plus X0 over 1 minus B 1 minus T minus M. So now we've learned how to solve this slightly more complicated model with foreign trade and government expenditure and taxation, as well as learning how that translates to a graph.